So let's quickly go through alcohols, what we got to know. So here we got to know about 15 stuff. Okay. 6 would be on preparation of alcohols. Then the other 9 would be on the reactions. You say 9, isn't it 10? Well, one of it we are going to kind of ignore it. And that's going to be aromatic substitution. It is mentioned, but then you don't have to know about it. So let's quickly go through this. The alcohols. So here we are going to go through 6 ways to make alcohols. 4 of them would be to make the general ones, and then these 2 would be to make phenols, okay, which is those alcohols that are when you have an OH group attached to a benzene ring. So first thing we're going to do is how do we come from alkenes, aldehydes, aldehydes and ketones, then carboxylic acids and esters, then haloalkanes. So from alkenes, we are going to do hydration. Okay, we are going to add water, but it would be acid catalyzed. Okay, there'll be an acid catalyst, and in here we are going to have to know a mechanism. There is a mechanism. Remember, there are only 4 mechanisms to know. One of them is going to be here. We're going to have to know the mechanism here. So how to make alcohols from alkenes, where we add water, but then we don't only add water. We add water and an acid catalyst. Okay, whatever acid it is, a strong acid. And then from aldehydes and ketones, how we make aldehydes, reduction. This is going to be reduction where we use NABH4. NABH4, okay, in ethanol, okay, dissolved with, so because we're going to dissolve our aldehyde in ethanol so that it can react to this NABH4. It can be reduced, right? It can be reduced to an alcohol from an aldehyde or ketone, okay? And then if you're doing from a carboxylic acid or ester, you're going to have to use LiAlH4. Again, another reducing agent, but here it's very strong, so we have to limit it by putting it in ether, that other organic group which you study. So, and then from haloalkanes, we want to now convert our halogen, okay, we sometimes call them halogenoalkanes, where we just have a halogen on an alkane, okay? And in here, we are just going to use a base, NaOH. We're going to put it, and then it is going to be able to react. Now, for these 2 guys, we say that make phenols, we have haloarenes and diazonium salts. For haloarenes, they work exactly like haloalkanes, only that the halogen is on an or a benzene. Let's say it's on a benzene. So what is going to happen is you are going to use again NaOH, but then there will be more conditions. It's going to be a 2-step process. When you put NaOH, you need to have temperature 623 kelvins. You're going to see it, and then 300 atm of pressure. And then on the second step, you just need to add hydrochloric acid. So first you add your base, like what you do to haloalkanes, but then you need some conditions. You need to put a little bit of heat, and then here's some pressure again, and then you finally add an acid. Okay, now what about for diazonium salt? You start with we start with an amine, so we're going to start with something called aniline. Aniline is a type of an amine where you have an amino group NH2 attached to a benzene, gives you aniline. And then when you have aniline, what you're going to do to it is you're going to add these 2 guys, NaNO2 and HCl. These 2 guys are used to make something called nitrous acid, HNO2, right? Where the H meets with the NO2, okay? And then you have NaNCO. So this is the guy which we will then put in our diazonium salt, and he is the guy that is going to lead to us having an alcohol. Anyway, we'll see what it is. But basically, what you got to know is that on preparation, I can have alkenes where I hydrate them, add water, aldehydes and ketones where I use NaBH4, which is going to be called sodium borohydride, okay? Sodium borohydride. Or sometimes you hear them say sodium tetrahydroborate. So that's one. And then here, lithium aluminum hydride, okay? Here it is lithium tetrahydroaluminate. It's another way. Either way, same thing. LiAlH4, NaBH4. So here what we have, this guy will be in ethanol. Here we have ether because it's a very, very hard reducing agent. It's very reactive, more reactive than NABH4. NABH4 only works on aldehydes and ketones. It's very selective. Then this LiAlH4, we use it for our carboxylic acids and esters. There we go. And it's going to reduce them to alcohols. And then here we have our things. So basically, we are going to go and look at these 6 first, make sure we know them. Then after that, we go to the 9 reactions, which you said we have these 9 reactions, and we'll see about this breathalyzer test, which is a type of oxidation. It's just an oxidation. All right, so we'll be done. And let's first look at the 6 ways to prepare them.